In this video, we're going into the deepening questions for our Switch Zoo online scenario. In the original website, we are given 28 possible heads, 24 possible legs, and 25 possible tails. What if we had 2 options for head, 4 options for legs, but only 1 option for tails? How many possible combinations will that be? Let's draw a table and a tree to explain our answer. All right, so we can solve this question by drawing a table. We can start by making 3 columns of our options, so that would be heads, legs, and tails, and then write out all the possible combinations in each row. I did so like here. I put 2 options for heads, and then with each head, there are 4 options for legs and 1 option for tail, giving us a total of 8 rows or 8 possible combinations. We can also solve this using a tree diagram. We'll do it very similarly. We'll have 2 heads, and then from each head, we'll have 4 options of possible legs and 1 option of possible tails. So counting that up, 1, 2, 3, 4, 5, 6, 7, 8, gives us 8 possible combinations. Now, there's an interesting thing you might notice. 8 is also the same number when you multiply 2 times 4 times 1. 2 being the number of possible heads, 4 being the number of possible legs, and tail being 1 for the number of possible tails. This is a quick trick for you to use for these simple combination questions. All right. In our next scenario, we have in the game, if we double the number of possible legs and double the number of possible tails, how many combinations are now possible? So instead of 24 legs, we have 48, and instead of 25 tails, we have 50. Now we can do a table and we can draw a tree diagram, but imagine how much time that would take drawing all of those combinations out. This is where our trick can come in handy by multiplying each of the options we have. So what we can do is we can multiply 28, which is the number of possible heads, times 48, which is the number of possible legs, times 50, which is the number of possible tails, to get 67,200 possible combinations. Awesome! Our next scenario. If we added 4 options for heads, how many new combinations are possible? So instead of 28 heads, if we had 32 heads, how would our combinations be? So similar to the last question, we can use our quick trick of multiplying all the options together, and we would get 32 times 24 times 25, giving us a total of 19,200 possible combinations. In this scenario, suppose that we want to add new options to the animal parts, looking to generate a total of 30,000 combinations. What should we do? Let's take a look at this question. So, one thing we can do is define some variables. We can make A the new number of possible heads, B the new number of possible legs, and C the new number of possible tails. We know that A, B, and C all have to be greater than their original numbers because when we put the original numbers together, we only get a total combination of 16,800, which is lower than 30,000. Now with these numbers, we can do some trial and error. What if A was 30, B was 25, and C was 25? This gives us 18,750, but it's still too low. How about A as 30, B as 30, and C as 25? It gives us 22,500. Nope, still too low. Now, how about A as 30, B as 40, and C as 25? We got 30,000. Awesome. So one possible solution, and please note that this is not the only one, is to add 2 heads, 16 legs, and 0 tails. Now another way we can do without having to do trial and error is factor. We can factor from 30,000 to get 30 and 1,000, and we can factor it down even more. The reason why we want to keep 30 is because we know that in the end it has to be 30,000. So something has to multiply by 30. And then one way of grouping can be seen here, where we group the 5s and 5s together to make 25, and then the 5s with 2s to make 40. And then we'll get 30 times 25 times 40, which gives us an additional 2 heads, 1 legs, and 15 tails. We hope that you liked our questions today, and we hope to see you in the meeting soon. Bye-bye.